welcome to Completing the Square. Now, just before we start, a quick reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so just to start with the phrase completing the square means to write a quadratic expression such as this, x squared plus 4x plus 6, in the form where we have x plus or minus a number in a bracket, all squared, with then a value at the end. This is a way of just rearranging things where we cannot factorise them straight away. And so with x squared plus 4x plus 6, the first thing I'm actually going to do is I'm going to ignore the value at the end. All I'm interested in is being able to make x squared plus 4x. Now, if I wanted to do that, there is a very simple method of doing so. Whatever this number is in front of the x, we will halve it. So x plus 2. And if I square x plus 2, what do I get? Well, x times x gives me x squared. If I add the 2 in there, well, that piece will be plus 2x. And if I added in 2 here as well, that would be plus 2x. And in here, if I did 2 times 2, I would get plus 4. So what have we got? Well, we've got x squared, which is what we wanted. We've got plus 4x, which is what we wanted. The problem is that this says plus 4, and what we were looking at in the original expression was plus 6. So how can I complete that expression? Well, again, there is a little method that I can use. I can subtract the value that I've just put inside of the bracket, so in this case plus 2 squared, because that would then remove this from my diagram. And then if I add back in the value that was in the original expression, then I'll be able to give the exact same thing. So if I simplify what I have just written down, I've got x plus 2 squared. If I subtract 2 squared, I've got to take away 4, but then if I add 6, well, that will be plus 2. And let's just check, does that make x squared plus 4x plus 6? Well, x times x is x squared, x times 2x is plus 2x, x times 2 is plus 2x, and 2 times 2 is plus 4, and then at the end plus 2. Simplify it all, this is plus 4x, simplify this, it's plus 6. And so I have x squared plus 4x plus 6, and so this is the exact correct answer. We'll try it again with x squared take away 6x plus 15. It's still the same. It's been asked for in the form of x plus a squared plus b. Now, what we did previously is we halved the number that was in front of x. Now, this is a negative, and this says plus a. That does not matter. The form x plus a could be x add a number or x take away a number. And so in this case, I'm going to x take away half of 6, which is 3. And I'm going to square it. Now, if I do that, well, that will be x squared take away 6x. That's good, but it will be plus 9 at the end. That is not what we have here. We have plus 15. And so, how am I going to get it into this form? Well, I will subtract the value inside of the bracket, negative 3 squared, and then I will add the value at the end, the 15. And so I will get from this x take away 3 squared. If I subtract negative 3 squared, well, negative 3 squared is 9. So take away 9 and then add 15. And if I work that out, that is x take away 3 squared plus 6. And that is in the form x plus a squared plus b. And then we're asked to write 3x squared plus 24x plus 50 in the form a brackets x plus b squared plus c. Now in this case, first thing to notice, we have a coefficient of x squared, which is different to the previous ones, but what you'll also notice is we have a value in front of the bracket this time. Now the key here is that this number in front of the bracket will generally be this number in front of the x, because again all I want to do here is I want to just separate off the first part of the expression, the 3x squared plus 24x, and find a common factor, and the common factor here would be 3. So it's 3 lots of x squared plus 8x, sorry. Now, if I wanted to do anything with this, well, I would be looking at x squared plus 8x. In the same way as we did before, let's try and create that by saying it's x and half of this value, x plus 4 squared, but still with the 3 in front. X plus 4 squared would give me x squared plus 8x, would it be plus 16, and we have 3 lots of this, and so 3 lots of this would be 3x squared plus 24x plus 48, which is very close to what we wanted at the top, but we actually wanted plus 50. And so what am I going to do? Well, I'm going to, in the same way as we did before, at this stage, at the 3 brackets, I'm going to subtract. But I'm going to subtract 3 lots of the number inside of the bracket, 4 squared, and then add the amount that's at the end, the 50. And what that's done is it's meant I'm going to take away 48, which is the 3 lots of 4 squared, and then add on 50. And so my final answer here is going to be 3 brackets x plus 4 squared, and then I have negative 48 plus 50, which means plus 2. So just for a general version of this, if we have an expression x squared plus bx plus c, then if we want to write it in completed square form, all we're going to do is we're going to place inside of the bracket x plus a half of b, and so x plus b over 2, and that's going to be squared. I would then subtract the value that is inside of the bracket squared, which is what I've done here, so subtract b over 2 squared, and then I would add on the value that was given at the end. This would give me the completed square form. If it happened to be ax squared plus bx plus c, well, in this case we would make it a brackets x plus, but in this case it would be b over 2a, because we would have divided this value in front of x, the b, we would have divided that by a already and then by 2, and that's going to be squared. And then we will take away the same thing again, the value that's on the inside of the bracket, so b over 2a squared, and then finally add on c at the end. Okay, so now we come to being able to use this completed square form in order to solve an equation. So we've been asked to solve x squared take away 24x plus 100 equals 0. Now the first thing just to note here, it is equal to 0. That is what all equations must be if they are quadratics and we are trying to solve them. We need to get them in the form of x squared plus something equals 0. And so we're going to complete the square first in order to actually get the answer. And so x squared take away 24x plus 100. First things first, that's going to be x take away 12, because we've halved the value in front of the x, and that's going to be squared. And then I'm going to subtract the value that's inside of the bracket, so that is negative 12 squared, and then add the 100. If I do that, I get x take away 12 squared. Now this is negative 12 squared is 144, so that's take away 144 plus 100, so that's subtract 44, and that equals 0. Now how am I going to actually solve this equation? Well, now the whole point is to get x on its own, and so I'm going to, as my next stage, I'm just going to add 44 to both sides, and if I do that, I get that x take away 12 squared is 44, and then I want to undo this squared, and so I'm going to square root both sides. If I square root the first side, well, I just get x take away 12. But on the right hand side, I'll have to be very careful here. I get the square root of 44, but the square root of 44 can be positive or negative. There are two different answers. And now the square root of 44, if I were to do that on a calculator, the square root of 44 would come up saying 2 root 11. And so I'm going to actually write it in that form. I'm going to say that this is x take away 12 equals plus or minus 2 root 11. It's written in surd form, and that's because we've got square roots involved. But if I want to get now x all on its own, I would have to add 12 to both sides. And if I do that, it tells me that x equals 12 plus or minus 2 root 11. And that is the final answer to that question. This is not something we're going to get an exact value for. Well, in fact, we have got an exact value. We've got 2 root 11 in our answer, so that is an exact value, but we're not going to get a nice decimal for it this time. It's going to be left in surd form. So let's try that again with solving x squared plus 12x plus 32 equals 0. So again, it already is equal to 0, so that's good. But in this case, all we now need to do is set this up in our completed square form. So that is going to be x plus 6 squared. And then I'm going to subtract the bit that's inside of the bracket, which is 6 squared. And then I will add 32. It's still going to equal 0. So x plus 6 squared, that will remain as it is, x plus 6 squared. But if I take away 6 squared, that's taking away 36, and then adding 32. So that's actually take away 4. And so it equals 0. If I were to then try to work this out, well, I need to get x all on its own. So the first thing I'm going to do is add 4 to both sides. And if I do that, I get x plus 6 squared equals 4. I'm then going to square root in order to get rid of the squared. And so that's going to be x plus 6. And if I square root 4, I get plus or minus 2. And finally, if I want to get the exact answer to this question, well, all I'm going to do is subtract 6 from both sides. If I subtract 6 from both sides, what is x equals negative 6 plus or minus 2. And because these are all just numbers here, we can actually get the actual answers. X would equal negative 6 plus 2, which is negative 4, or negative 6 take away 2, which is negative 8. And so x is negative 4 or negative 8. And so finally we come to one of the main benefits of the completed square form, that it allows us to find the coordinate of the turning point of the curve of a quadratic graph. So we're looking at the graph y equals x squared plus 2x take away 7. Well, I'm just going to start by drawing a little sketch of what this graph might look like. Now, this negative 7 at the end tells me that it crosses the y-axis at negative 7. And this graph is going to look sort of like this. It's going to be a positive x squared graph, and so it's going to have the U shape, and it's going to cross at negative 7. And so all I want to do is see how this this expression can be turned into completed square form in order to find the turning point, which is actually the absolute minimum point of a quadratic graph. Well, let's have a go. So if I completed the square, I would have x plus 1 in the bracket and squared. I would then take that 1 squared away, and I would then add in the c value, which is -7. If I simplify that, I get x plus 1 squared, and take away 1 and take away 7, that's -8. Now this at the moment doesn't seem to have given us anything about this graph, but what it has done is it's given me a coordinate, because the first part is all to do with x. Now in order for this to give us an x coordinate, we need the negative version of what is inside of the bracket. The negative version will be -1. This part is giving me a y coordinate, because what we're actually saying is that y equals this, and so y equals -8. And so this point, the minimum point, the turning point of the quadratic graph, will be -1, -8. Okay, so we'll try that again. Find the coordinates of the turning point of the curve with equation y equals x squared take away 10x plus 20. Again, a little sketch of this would show us that, first of all, it crosses at +20. So, like that. It's going to be a U shape, and it's going to look sort of like that when we draw it. So let's have a see if we can find that minimum point, this position where it is turning. So let's go to the completed square form. So half of the -10 is -5, and that's going to be squared. I will then subtract the value in the bracket, squared, and add on the c value, which is 20. And so that gives me x take away 5 squared. The -5 squared is 25. Take that away, that's -25 plus 20, well, that's -5. If this is going to give me a coordinate for the turning point, the x value is going to be the negative version of what is inside of the bracket, so 5. And then the y value is going to be what is at the end, -5. And so this point here is 5, -5. The turning point of that graph is 5, -5. And so we're going to end with the exam question. It came from the Edexcel paper in November 2018, and it was on higher paper 1. And what we've been given is a sketch of a curve, and we've been told that the equation of the curve is y equals x squared plus ax plus b, where a and b are integers. The points 0, -5 and 5, 0 lie on the curve. Find the coordinates of the turning point of the curve. Now this question's got an awful lot involved in it before we get to this section, which is the completing the square. The first thing is we don't actually know what the equation of the curve is, and so we need to work that out. And so that is all going to come from the coordinates we've been given. Now in the first one we've been told 0, -5. So that means that when x is 0, y is -5. And so if we go to the version we've been given, we've been told that when x is 0, y is going to be -5. So let's fill that in. So y is -5 when x is 0. So x squared is 0, ax is 0, and so we're just left with b. And so b is -5. So straight away we can now say that this equation, y equals x squared plus ax take away 5. So then when we come to the second coordinate we were given, we were told 5, 0. So that said when when x equals 5, y equals 0. So let's place that into the equation. When y is 0, x is 5, so that's 5 squared plus 5a take away 5. So let's try and find a. Well, 5 squared is 25, and negative 5 at the end equals 0. And so 25 take away 5 is 20. And so I'll subtract that from both sides. It leaves me with 5a. And so negative 20 equals 5a. So we divide by 5. So a equals negative 4. And so what that tells me is the equation of the curve must have been y equals x squared take away 4x take away 5. And so that is the equation. Now that is enough to now get us the turning point, because what we're going to have to do, if we're finding the turning point of a curve, we need to complete the square. And so this x squared take away 4x is going to become x take away 2 squared. I'm going to subtract my negative 2 squared. Let's remove that from the situation and then bring in the negative 5. So that is x take away 2 squared. Negative 2 squared is 4, so that's take away 4, take away 5, well that is negative 9. And therefore the turning point, all we then need to do is look at this as a coordinate. We want the negative version of negative 2, so that's positive 2. And we want the value that is at the end, negative 9. And so the turning point would be 2, negative 9.